the worksheet, there was this integral problem, and this right here. This is one of the 7.2 worksheets. And so the reason I'm going to solve this one is because a lot of people are having trouble with it, and B, because I think that there's a very unique and interesting solution to this. I think especially relative to the other, how you say, integral problems, I think it's a very unique one. I think it's actually a little beautiful in the sense, and I think it shows a lot of techniques or ideas on how to apply integration techniques. So obviously this is a use of problem. So this integral would actually encourage you to complete the square. I actually recommend you don't do this. And why? Because there's a more unique way to solve this. So what you can actually do is notice that this is actually a difference of squares. And so what we can do actually is we can rewrite this integral actually such that it's 2 plus sine x, and we're doing this based on the difference of squares, 2 minus sine of x, right? And so this is actually much easier to solve because what we can do now that we've done this is that we can set u equal to sine of x, and we take the derivative of this with respect to x, and we'll get that du dx is cosine x, which, if you notice, is in the numerator right here. So if du is cosine x dx, that means du over cosine x is equal to dx. So what we do is we rewrite this integral now in terms of u. So we write cosine x, 2 plus sine x, 2 minus sine x. Well, actually 2 plus u, 2 minus u. Is equal to du over cosine x. We multiply these. So we eliminate this, and we'll get the integral of the root of 2 plus u, 2 minus u, and bam. And we'll get du over root 4 minus u squared. And from here, we can do your classic method of taking out the 4. And I'm going to continue this here, actually. Your classic method of taking out the 4, which in this case would be, yeah, so if we rewrite this as du over root 4 1 minus squared over 4, which is really nice. We can factor out 1 over 2 because root 4 is 2, and you can factor this out because it's multiplied. So 1 over 2, this is really 1 over 2 du 1 minus u squared over 4. Don't forget the root is important here. And this is just a basic trig identity. Not a trig identity, but like an integral trig identity, you know what I mean. So this would be, since u over 2 squared is equal to u squared over 4, this will be 1/2 arc sine u over 2, or plus c. Now we replace our u. As we see, we put our u as sine x, so 1/2 arc sine of sine of x 2 plus c. I actually forgot to multiply by 2 at the end, so when you integrate this, you have to multiply by 2 because of the way the formula works. So that's my bad. I'm a bit of a bot for that. So so it's actually arc sine sine of x over 2. My bad. That's nothing to do with the integration technique. It just was being a bot and forgot the chain rule for some reason. So this would be the answer. My bad. But my point still stands. So what does this tell us about integration? Well, the first, I think, method that this really shows us is that try and manipulate the function in such a way such that the derivative of u is able to cancel out the numerator of the rational. For example, the only reason I knew of this method or knew that this method would work was because I knew that the derivative of sine of x was cosine of x, and that cosine of x was the numerator. So if I just completed the if I used the difference of squares formula and took the derivative of sine of x, this would just eliminate the numerator and make the problem a lot easier. Second is, don't be afraid to algebraically manipulate the integral to make it easier. That's like 90% of Calc 1 and Calc 2. Just a quick video. It's 11:50 p.m. There's another video. There's another like actual Makurji video in the works. I just thought that this might be helpful because a lot of people in my general friend group were a little iffy about this problem specifically.